Hello everyone, welcome to the channel. What does it take for a function to be continuous at a point? In this video, we are diving straight into solving problems on continuity. We will break down the steps to check if a function is continuous at a specific point using limits. And I will guide you through some common examples and tricks to make the process easier. By the end of this video, you will have all the tools you need to confidently solve any question about continuity at a point. Let's get started. So a function f is said to be continuous at a point C if limit as x approaches that point of our function is equal to f evaluated at that point. Now this is the same as limit as x approaches the point from the left and limit as s approaches the point from the right of f of x. And this should be the same as the function evaluated at that point, right? So basically what this is saying is that for a function to be continuous, you have to check for these three things, or you can check for this and this. Okay, let's go ahead. For our first question, for what value of a is f of x, which is equal to this piecewise function, continuous at every x. Now to solve this problem, we first of all have to write our condition. So for a function to be continuous at a point, we want the limit as x approaches that point. Remember, the point in question is 3. So 3 from the left of our function should be equal to the limit as s approaches the it from the right for f of x, and this should be equal to f evaluated at that point, so 3. Okay, so now let's move on. So we have limit as s approaches 3 from the left. Now let's go back to the piecewise function. Approaching 3 from the left means we have to use this one, the less than sign right here. So the corresponding function is this, s squared minus 1. So we have s squared minus 1. This is equal to limit as s approaches 3 from the right. From the right, we have greater than right here. So we have 2ax, and this is equal to f of 3. Now, let's just simplify this part right here, right? So with this, remember from the previous video, all that you have to do is to put in the value. Now 3 from the left doesn't necessarily mean that we are going to put a number that is less than 3. All that we have to do is to put in 3, and if there is a problem, that is where you consider the numbers that are lesser than 3, right, but very close to 3. So in this case, we just put in 3. So we have 3 squared minus 1. In this case, 3 from the right, we just have to put in 3. So wherever we see x, we put in our value. And f of 3 basically means when x is equal to 3. So x greater than or equal to 3 means x is greater than 3 and x is also equal to 3. So it also corresponds to 2ax. So we just have to write 2a, then we change the x to 3. So clearly we can see that these two are the same. So going forward, you can just write one of them. So 3 squared is 9, 9 minus 1 is 8. And if you multiply these two, we have 6a. So to find a, we just have to divide through by 6, here by 6. So this cancels that. So we have our a to be equal to 8 out of 6. Now we can divide it again for us to have 4 over 3. So this means that when a is equal to 4 out of 3, our function is going to be continuous at every x. Let's move on to the second one. For the second one, using the same thing, right? For what value of x, we'll make this function a squared x minus 2a than 2, then 12 when x is less than 2. Continuous, right? At every x. So again, the condition limit as x approaches, now our c is 2. So we have 2 from the left of f of x should be equal to limit as x approaches 2 from the right of f of x, and this should be equal to f of 2. So now let's do our substitution. From the left, we use the less than, right? So we just have our f of x in this case is 12. From the right, we use greater than. So in this case, we have a squared x minus 2a, and this is equal to f of 2. Remember, the limit of a constant is always that constant. So we have 12 over here. And now for this part, we just have to evaluate it at 2. So wherever we see x, we put in 2. So we have a squared times 2 minus 2a is equal to f of 2. Now what is f of 2? F of 2 means when x is equal to 2, what do we get? We get the same thing, right? So we are going to get the same thing as a squared 2 minus 2a. Now since this is 2, we have to drop 1 and continue with 1. So let's say we pick this and that. So we have 2a squared minus 2a is equal to 12. We can send the 12 to the left hand side. So we have 2a squared minus 2a minus 12 is equal to 0. So now, let me rewrite it properly. We have 2a squared minus 2a minus 12 equal to 0. So we can just divide by a common term, which is 2. So we have a squared minus a minus 6, and this is equal to 0. So we have to factorize this. Remember, with this question, the coefficient over here is 1, here is minus 6. We have to find the factors of minus 6, right? Remember, it's both positive and negative. So this is it. Now we have to select two numbers that if we add, we have the coefficient here, which is 1, negative 1, and if we multiply, we get negative 6. So we can have a squared. Then which two numbers can we select? Can we select minus say plus 2a minus 3a. So if you pick 2 and minus 3, if you add them, you have minus 6. If you add them, you have minus 1, but if you multiply, you have minus 6. So I think that works. Minus s equal to 0. So we factorize by grouping, right? So we have a, then a plus 2. Then for the second term right here, we can have minus 3, then a, then this is plus 2 equal to 0. So this simplifies to a minus 3 and a plus 2 equal to 0. So a minus 3 equal to 0 simply means a is equal to 3. A plus 2 equal to 0 means a is equal to minus 2. So therefore, when a is equal to minus 2 or 3, then our function is going to be continuous at every point of x. I hope this explains it. Let's move on to the third one. For the third one, we have this piecewise function, minus 2, when x is less than or equal to minus 1, ax minus b, when x is in between negative 1 and 1, and positive 3 when x is greater than or equal to 1. So we have this piecewise function. Now let's write. In this case, note that we don't have just one value. We have negative 1 and positive 1. These are two values, meaning we have to get two different equations. So for the first equation, we have limit as x approaches. The first one is negative 1. So negative 1 from the left of f of x, this should be equal to limit as x approaches negative 1 from the right of f of x, and this should be equal to f of negative 1. For the second equation, so this is equation 1. For the second equation, we can have limit as x approaches the second value, which is 1 in this case, from the left, and now 1 from the right of f of x, and this should be equal to f of 1. And we can name this equation 2. So now let's talk about equation 1. For equation 1, we have limit as s approaches negative 1 from the left. From the left, meaning it's less than, right? So we have just minus 2 here. This should be equal to limit as x approaches negative 1 from the right. Now, from the right, what does it mean? It means this is negative 1, right? We go to have the number line. This is we have negative 1, we go to 0. Now, if we are approaching negative 1 from the right, it means we are coming in this direction. So we want numbers that are bigger than negative 1, right? But not negative 1. So we are going to find that over here. So with this domain, we can say that s is greater than minus 1, but less than 1. So it means that from the right, we can pick this piecewise function, which is ax minus b, right? I hope this makes sense. So we can have ax minus b here, and f of negative 1 is just minus 2. So we have this. And remember, limit of a constant is that constant. So over here we have negative 2, which is the same thing as this. So we can just drop one of them and continue. So now we have minus 2 here. If we put in negative 1, wherever we see x, we have a times minus 1 minus b. So this is minus 2 equal to minus a minus b. So this is, if we divide through by negative, then we have a plus b is equal to 2. This now becomes our equation 3. Now let's move on to equation 2. For equation 2, we had limit as x approaches 1 from the left of f of x. Now, from the left means we want values that are lesser than 1. So meaning we have to come over here, right? Now the corresponding function is just ax minus b. This should be equal to limit as x approaches 1 from the right of f of x. Now when x is greater than 1, we just have 3. And this is equal to f of 1. And when x is equal to 1, we also have 3. So we have this. Now if we sub in 1 where we see x, we have a multiplying 1 minus b. The limit of a constant is that constant, so we have this. So in this case, we have a minus b is equal to 3, and we can have this as equation 4. So the next thing to do is to solve the equations simultaneously. So we have a plus b is equal to 2, and now a minus b is equal to 3. We can solve by elimination. So we can add equation 3 and equation 4. If we do that, a plus a, meaning we have 2a. B minus b goes to 0, and 2 plus 3 is just 5. So if we divide through by 2, it means a is equal to 5 over 2. To find b, we can make b the subject in either equation 3 or equation 4. Let's say we make b the subject in equation 3, meaning b will be equal to 2 minus a. So b is equal to 2 minus, now a, we know it to be 5 over 2. So this is just 4 over 2 minus 5 over 2, which is equal to minus 1 out of 2. So our answer is if a is equal to 5 over 2 and b is equal to negative 1 out of 2, our function f is going to be continuous at every x. I hope you understand this as well. Let's go to the next question. Our next question is our piecewise function x squared minus 3x plus 2 out of x minus 2 and 0 over here. Now this is when x is not equal to 2, and this is when x is equal to 2. Is this piecewise function continuous at x is equal to 2? Now let's solve this. Remember, from the definition, right, for a function to be continuous, we have to get this, right? So this means that to solve this, we can have limit as x approaches, now the c is 2. So as x approaches 2 of f of x should be equal to f of c. Our c is just 2. Okay. So limit as x approaches 2, meaning that x is not equal to 2. So if x is not equal to 2, then we have to use this, right? So we use the first one. So we have limit as x approaches 2 of x squared minus 3x plus 2 out of x minus 2. And this should be equal to f of 2. Now when x is equal to 2, we have our function to be 0. So we have 0 right here. So basically, the idea is for our function f to be continuous at x is equal to 2, if we solve this limit right here, we have to get 0. Okay, so now let's solve the limits. So we are just dealing with the left hand side, right? We have this. So just as we've been doing, let's first of all put in 2. So we have 2 squared, meaning 4 minus 3 times 2, which is just 6, plus 2 over 2 minus 2. So this simplifies to 6 minus 6 out of 0. So this is 0 over 0. Now we don't want this indeterminate. So remember, whenever you have a polynomial, you can just factorize. So how do we factorize this? So first of all, let's factorize x squared minus 3x plus 2. Now this coefficient is 1. We multiply it by 2, so we just want the positive and negative factors of 2. Now which two numbers can we pick that if we add, we have -3, but if we multiply, we have 2. So in that case, we can pick -1 and -2. Note, this we have -3x. And if we multiply them, we have +2. So that works. Okay. So we do by grouping. So now we have x minus 1, minus 2, and this is just x minus 1. So the numerator simplifies to x minus 2 and x minus 1. So now let's continue right here. So we have limit as s approaches 2 of our numerator, which is now x minus 2, x minus 1, over our denominator, which is just x minus 2. So clearly, we can see that this will cancel this. So all we have left is limit as x approaches 2 of x minus 1. So now let's put in 2. If we do that, we have 2 minus 1, which is equal to 1. But note, we said for the function to be continuous at 2, we have to get 0. And now we had 1. So since limit as s approaches 2 of f of x is not equal to f of 2, f of x is not continuous at s is equal to 2. I hope this explains the concept of continuity at a point. As always, if you have any extra problem or any question regarding this video, just drop a comment and I'll just do my best to give you a response as soon as possible. Also, do not forget to give a thumbs up, then subscribe and share this video. I'll see you in the next one. Take care.